Today we're going to be doing the first video on number theory and arithmetic foundations, and it's going to be about divisibility and divisibility rules. Why are we starting here? Because a lot of numbers, we're going to be trying to break them down. And how do you test quickly whether a number can be divided by a certain number? That's what today's about. So that's going to be used a lot in the future. So this video is going to have two parts. The first part, we're just going to go through the rules. Second part, we're going to prove why the rules work. So most of you already know a lot of these. So to test whether a number is divisible by 2, the rule is you check whether the last digit is even. So it ends in 0, 2, 4, 6, or 8. The ones in the boxes are the rules that some of you might know, but a lot of you might not. So those are kind of the new ones we're going to focus on. To test whether a number is divisible by 3, you sum the digits of the number. And if that sum is divisible by 3, then so is the number. For 4, you look at the last two digits. So if you want to check 572, you just need to check whether 72 is divisible by 4. For 5, it's whether the number ends in 0 or 5. For 6, I left it blank because we don't need a separate rule for 6. We're just going to use the 2 and 3 rules because 2 and 3 multiply to 6. Now this works the same if you want to do the rule for 36 would be the rule for 4 and 9, so you would look up the 4 rule and the rule for 9. Okay, so the rule for 7, I'll say more about that later. The unhappy face means that there is no rule. Now you may have heard teachers say that there is no rule. That's technically incorrect. So the unhappy face technically means that the rule sucks. So there is a rule, but it's not good and it's not useful. So unless your day job is to divide by 7 all day, in which case you would want to memorize that rule, we'll assume there's no good 7 rule, or at least not one that I know of. The 8 rule. So the 8 rule is you do the last 3 digits of the number. So if you want to test 5,272, you just need to test the last 3-digit number. So if 272 is divisible by 8, so is the entire number. Alright, the 9 rule is the same as the 3 rule, except the sum of the digits has to be divisible by 9 as opposed to by 3. The 10 rule, the number has to end in 0. I think a lot of you guys know that. The 11 rule, I put a star just because it's for 2 reasons. A, it's a little trickier to remember, but B, it's not that important. It's more of a fun rule, so don't focus too much on the 11, but hopefully you enjoy the 11 rule as well. So the real rules we want to focus on today are the 3, 4, 8, and 9 rules. So now we're going to prove the 3 rule. To do that, we're going to assume we have a 4-digit number such as 2,345, except this is not a proof because this is a specific number. So we're going to assume the digits can be anything. So we'll use a 4-digit number. So A can be any digit from 1 to 9. B can be 0 through 9, 0 through 9, 0 through 9. So this will make it general. Now one other thing I should say, so a quick note, this is not a multiplication of letters. This is not A times B times C times D. These are just digits. The other thing is this is technically not a full proof we're doing, because a full proof would accommodate the fact that this could be any size number. It could be 1 digit, 2 digits, 5 digits. So to do that, we might extend it and say there's a first digit, a second digit, all the way up to an nth digit. And the proof would work very similarly. I'm not going to do that just so we can focus on a specific example, but this will be the complete proof running it this way. Alright, so now our goal is to write this in expanded notation. So just to remind you guys, we would write this out as 2,000 plus 300 plus 40 plus 5. These are just the place values. So it's 2 times 1,000, 3 times 100, 4 times 10, 5 times 1. So let's do the same thing here. So this number is really 1000A plus 100B plus 10C plus D. All right. Now actually, I'm going to switch gears for a second. I said we're going to do the 3 rule. Let's do the 4 rule first. Let's take a look at this number 4 and these numbers here. So that's basically a 1D. I wrote D, but that's the same as saying 1D. There's 1 of these, 10 of these, 100 of these, 1,000 of these. Now, is 1 divisible by 4? It's not. So we don't know whether the D is divisible by 4 unless we're given the value for D. So if D is 5, it's not divisible. If D is 4, it is divisible. If D is 8, it's divisible. 10 is also not divisible by 4. So unless C happens to be even, this won't be divisible by 4. All right. Now 100 is divisible by 4. So that means no matter what B is, this part will be divisible by 4. So we could throw this part out. That's not going to mess us up in our divisibility test. Neither is 1000 because 1000 is divisible by 4. So 1000 times any digit is still divisible by 4. So if you want to take a number like 2345, 300 is divisible by 4, as is 2000. So really, this part is garbage, and that's where we get the rule of checking just the last 2 digits, because we're just left with this part right here. Now for 8, the only thing that would change is 100 is still not divisible by 8. It gives us 12.5. So the only thing that starts to be divisible by 8 is the thousands place onwards. So that's where we have to throw. We can throw this away, but we still have to check the last 3 digits. So that's where we get this rule of the last 3 digits. So the 4 and 8 rules are pretty quick to see just from here. For the 4 rule, we threw both of these out. For the 8 rule, we just threw this out. So we were left with these 3 digits. All right, let's go to the 3 rule. So for the 3 rule, our job is to chop this ugly looking thing down and make it as simple as possible. The simpler we make this, the nicer the rule. So we're going to leave the D as a D, because unless you tell me the value of D, I don't know whether it's divisible by 3 or not. Now 10C, we are going to split into 9C plus C. Why did I do that? Because 9 times a number times a whole number digit will definitely be divisible by 3. All right, let's do the same for 100. And we'll do the same thing here. All right, so this says 999A plus 99B plus B plus 9C plus C plus D. And now why did we do this? Because now we can throw this out, because this is surely divisible by 3. 99 times any whole number is surely divisible by 3, so that's gone. And 999A is also divisible by 3. So that's gone, and so is my marker. All right. So what are we left with? We're left with the A, the B, the C, and the D. So that means instead of checking this sum, which amounts to our original ABCD number, we just need to check the sum of the digits, which is exactly the rule for 3. Now we're not going to prove the rule for 9 again, because it would work exactly as follows. Exactly the same way. The only thing that would change is we might say, hey, maybe we have to split these differently, but we don't have to, because 9 is still divisible by 9, as is 99, as is 999. So the splits would work the same way, and then we would just have to check that the sum of the digits is divisible by 9 instead of 3. So the 3 and 9 proofs are very similar, nearly identical. All right, now that's the core part of the video. Now for the superheroes among you, we're going to prove the 11 rule. Actually, before that, let's prove why the 7 rule is really bad. So for 7, we're going to leave this as it is because we don't know anything about D. For this, we're going to split it into the highest multiple of 7 under 10 So that would be 7c plus 3c. Now, this is not 70. We're going to do 98 because that's the highest multiple of 7 under 100. These are added. All these terms are added. And this one would, again, I'm not even going to bother with that one. So the point is we're going to cross these things off. And now you're going to get 2b, 3c, and 1d. So notice these numbers in front of the variables, or these coefficients, the 2, the 3, and the 1d. Who's going to remember 2, 3, and 1? And if you keep going, these numbers are not going to stay the same way. So they're going to be really ugly numbers. So whereas the 3 rule was just sum the digits, the 7 rule would be take twice the hundreds digit, add 3 times the tens digit, and 1 time the ones digit. Now, I don't know about you guys, but I'm not going to remember that, and I don't think you guys should either. So there is a 7 rule, but it sucks. All right, so now let's do the 11 rule. So the 11 rule, again, we're going to keep the d as it is. Now we're going to do something kind of tricky here. Instead of going forward trying to see what's 10 divided by 11 and writing it just as 10c because we can't fit any 11s into 10, we're going to overstep and go backwards. Why are we doing that? So that we can get closer to 10. So we're actually going to overstep to 11 and go backwards 1. Here we're going to go to 99, b plus b, because that's the closest multiple of 11 to 100. And here we're going to go to 1001a minus a. Now notice in these two we're doing our traditional splits where we're just under the numbers, and in these two we've overstepped them by a little bit, because this way we're much closer to these numbers than being 10 away. All right, so now when we cancel off the parts that are definitely divisible by 11, we're left with minus a plus b minus c plus d. And if you keep doing this, you'll find that these signs alternate. So it's just like the 3 or 9 rules, but you don't add up all the digits, you add up the alternating sum of the digits. So for example, if you want to do 1001, you see, okay, 1 minus 0 plus 0 minus 1, is that a multiple of 11? Well, it's 0. 0 is divisible by 11. It's just 0, so it works. You could try 5, 1, 6, 0, 1. So now you could think of it as actually adding up these alternating sums, so that's 12. And now we're going to subtract off this sum, which is a 1. So 12 minus 1 is 11. And so 11 is divisible by 11, and so is this number. Now, if that seems a little convoluted, like I said, this is a bonus trick. So don't worry if this is not your thing. Focus on these main tricks, and for those of you that are ready, you can include the 11 in your arsenal as well. All right, I'll see you guys in the next video.